So here we're going to solve the problem. The integration of sine mx cosine nx dx, where m and n are constants and m is not equal to n. So here we're going to apply the product to some formula, which is sine alpha cosine beta is equal to 1/2 cosine alpha minus beta minus cosine alpha plus beta. So here, once we apply this formula, we'll get sine mx cosine nx dx. So here, 1/2 times cosine mx minus nx minus cosine mx plus nx dx. So here we're going to distribute our integrals and put our constant out, which is our 1/2. So 1/2 integral of cosine mx minus nx dx minus 1/2 integral of cosine mx plus nx dx. So here we're going to use substitution. So let u be equal to mx minus nx. Since we could actually bring out the common factor, which is x, here we could easily derive u equals to m minus n dx. Next is we let w be equal to mx plus nx and take out our common factor, which is x, and easily derive our w, which is dx. So here we could easily substitute our values. We have 1/2 is equal to the integral of cosine u times, since we have our du right here, to get our dx, we have to multiply both sides by m minus n, giving us with minus 1/2 integral of cosine w. And again, same with du here. Divide both sides by m plus n, giving us with there. Next thing we do is we let out, since m and n are constants, we could bring them out the integral. That's m plus n, sorry for that. There. Next up is we integrate our values, since we could easily integrate them already. Let's write it properly. Minus 1/2 m plus n sine w plus c. Here we're not done yet. We still have to substitute the values of our u and our w, which are for u, we have mx minus nx. That one. And for our W, we have mx plus nx. Oops, we forgot m plus n here. So that's our final answer.